Lesson number 6, instructional video, conditional and converse statements. A conditional statement. A conditional statement is another name for an if-then statement. Within a conditional statement, there are two parts. The if part is called the hypothesis. The then part is called the conclusion. Truth value. Truth value is asking, is a statement true or false? Counterexample. A counterexample is an example that shows something is incorrect. First set of problems. It's asking you to identify the hypothesis by circling it, the conclusion by underlining it, and the truth value of each conditional. Letter A. It says, if 3x plus 4 equals negative 5, then x equals negative 3. The hypothesis is the part after the if statement. The conclusion is the part after the then. If this happens, then this will occur. Truth value. Is this statement true or false? This statement is true. Letter B. If you take a class in television broadcasting, then you will film a sporting event. The hypothesis is the part after the if. So we're dealing with if you take a class in television broadcasting, please do not include the word if in your hypothesis. If is always there. The conclusion would be then you film a sporting event. I'm trying to underline that. Thinking about the truth value, is this true or false? False. Just because I take a class in television broadcasting doesn't necessarily mean I will film a sporting event. There are lots of things we could do in television broadcasting other than sports. Determine the truth value for each conjecture. Give an example for any false conjectures. If S, T, and U are collinear and ST equals TU, then T is the midpoint of segment SU. Conjecture is the idea of putting something out there. So I'm saying, what is the truth value of this statement? In order to do this, because there are quite a bit of letters, vocab, collinear, midpoint, let's give it an example to draw it. It says that if S, T, and U are collinear. Collinear means that things lie on the same line. So I'm going to have S, T, and U. If all of them lie on the same line, and it says that S to T equals T to U, meaning these lengths are equal, then T is the midpoint. Yes, if these two segments are of equal length, as said by this statement here, and they all happen to lie on the same line, then yes, T would be the midpoint. It would have to lay exactly in the middle in order for that line segment to equal that line segment. The second one, it says if angle 1 and angle 2 are adjacent angles, then angle 1 and angle 2 form a linear pair. Here you do have to have an understanding of the vocab. Adjacent angles mean side by side, meaning that they have an arm in common. Here would be adjacent. There's another example of adjacent. Here's an example of adjacent where two angles have an arm in common. So if angle 1 and angle 2 are adjacent, then angle 1 and angle 2 form a linear pair. Could they form a linear pair? They could, as I drew right here, but do they have to form a linear pair? Not necessarily. I drew two angles that were adjacent and didn't necessarily form a linear pair. When it asks for counterexample, a counterexample is anything that shows that something is not true or that anything is false. So your counterexample here could be you drawing a set of complementary angles that are adjacent, or two angles that are adjacent and don't add up to any one number in particular. Number 4, write each statement as a conditional. This is where my students start to stumble a little bit. You need to take these statements and introduce an if and a then. If something happens, then the result will be. Very often you're going to have to do a little bit of kind of English clarification for your sentence. So for instance, those who do not remember the past are condemned to repeat it. written as a conditional statement, could look like, if the past is not remembered, then we are condemned to repeat it. I did have to add some words in there to make it grammatically correct. Looking down below, adjacent angles share a common vertex and a common side. One example could be, if angles are adjacent, then they share a common vertex and a common side. Very often I have students say, if it is adjacent, if they are adjacent. Please make sure that you're using the proper, or you're using the word prior to a pronoun. I talk about they meaning angles. We can't say if they are adjacent, then they share a common side. What would they be? In addition, I do want the order of it to be here. Because we're talking about adjacent angles, what are adjacent angles? They share a common vertex and a common side. It does need to be presented in that order, not the other way around for this particular case. Number 5 is going to take us into the idea of a converse. Write down converse in the vocab box at the top of your page. The definition of converse is an if-then statement where the hypothesis and the conclusion are reversed. Here is my example. If an object is glass, then it is fragile. That is a true statement. Its converse would be where you turn these around. If an object is fragile, then it is glass. Is it true the other way around? Not necessarily. An object that could be fragile would be a plate or something, a piece of pottery made out of porcelain, not necessarily made out of glass. If an object is fragile, my grandmother's fragile. If she falls down, she's going to break something, but she's not made out of glass. Number 5, it says write the converse of each statement and determine its truth value. What would the converse be of if you see lightning, then you hear thunder? If you think back to this being the hypothesis, this second part being the conclusion, the idea of a converse statement is the hypothesis and the conclusion are reversed. So take a look at the following statement. If you hear thunder, then you'll see lightning. What is the truth value of that statement? False. You can hear thunder without necessarily seeing the lightning. Second one, it says if two lines intersect to form right angles, then they are perpendicular. Here's your hypothesis. It's pretty long. Here's the conclusion. So when you talk about a converse, the converse switches the hypothesis with the conclusion. So take a look at the following. It's in here somewhere. There it is. If two lines are perpendicular, then they will intersect to form two right angles. That is a true statement. Not only was it true the first time as its original conditional, but the converse is true as well. And that concludes the instructional video for Unit 1, Lesson 6. Please let me know if you have any questions. Thank you.